In this video, we'll complete our base end panel by making a toe kick in the bottom right corner, and we'll use the routing commands to make the toe kick. So what we want to end up with is a toe kick that's 100 millimeters tall and 75 millimeters into the base and then comes out the end. So we'll start below the front edge of the end panel, go in 75 millimeters and come out the end. So the first step we need with routing is to go to what we call the mill setup command. This is the first step. The second step after a mill setup is to attach either a straight line or an arc, or both. So let's start off with the mill setup. I'm going to go to the mill setup command, and we're prompted to enter the X, Y, and Z coordinate, a tool number, and compensation. So let's start off with the X coordinate, which if we want this to be 100 millimeters off the edge, that's length minus 100. Our Y value, let's start 25 millimeters outside the panel. So we know this in our Y coordinate that the bottom edge of the panel here is 0. So if we want to be 25 millimeters outside, that's a value of minus 25. And then we want to cut all the way through the thickness. And we know our panel is 19 millimeters thick, so we could just tell it, let's go minus 19.1, for example. But we know that we want to, use parametric values like we do with length and height. So looking at the bottom of the screen here, we have our length, height, and thickness parameters. And thickness is always S. So if we want to cut through the panel, then we remember that our Z values into the panel are negative, with the top of the panel being 0, into the panel being negative. So if we want to go through the panel, then we have to give it a value of negative S. And if we want to go through 1 millimeter, then we just give it minus S minus 1. And that means the bottom of the tool will be 1 millimeter under the bottom of the part. So we know that we'll cut through by 1 millimeter. Next, we need to pick a tool. And like with grooving, if we know the tool number, we can just type it in. Or we can click this control and we can bring up our tool parameter window. And we can select the tool that we've created over in tool parameters. We can't edit these parameters here, but we can just view them and select the tool. If we click this large arrow, then we can see all the tools that are available for this particular job and pick one of those. So if we want this tool 1001, which is a 1/2 inch compression, we just double click it, select it, and cancel to get out of the tool selection. And then finally we need to set a tool radius compensation. So as we said, we're going to start below the panel, move up in this direction, and come out. So we want our tool to be on this side of the line that we're programming, so that we know that we're exactly 100 millimeters to the inside edge after we've cut it. So we want our tool to be on the right hand side of the line as we move in this direction. So that's right hand compensation. I'll click on right, and we hit OK. We can see draws a circle with the actual diameter of the tool to scale, and it starts 25 millimeters outside the panel as we've asked it to. So next, let's go to linear milling. Let's attach 2 straight line segments. In this case, like drilling, we get the coordinates of the line before, which is from our set mill. So we only need to change the Y coordinate if that's the direction we're moving, and we want to go to the point 75 millimeters in Y. And then we want another line segment, so we come back, click linear milling again, and we go to the X coordinate, and we want to go 25 millimeters outside the panel. So that's length of the panel plus 25. Alright, so now we've routed our toe kick. Now let's go verify our tool compensation. Before we do that, let's zoom in on it. And if we go up to radius compensation, turn that on, then you can see we get an extra line, and it's to the right hand line of what we programmed. This line that's just turned on, we can turn it on and off with radius compensation. But this line that turns on represents the center of the tool. So we know that we're compensated to the correct side of the line that we programmed, and what's left is what will be left is what we've programmed. So we know that this line will be 100 millimeters from the bottom edge of the panel. The tool will be on the inside of that. There's another control that'll help us visualize the tool path, and that's called the profile trench. So we turn this on, and we can see the actual diameter of the tool as it makes its way through the panel. And we can even, if we zoom in further, we can even have an idea of what the radius that'll be left, or the material that'll be left in this corner, and that's based on the diameter of this tool. Had we used a smaller diameter tool, we'd have had less material left here. But this is the Genesis draws this line, or this polyline, if you will, based on the width of the tool from tool parameters. So it's an accurate representation to scale of what the tool path will look like when it's actually cut. So we've introduced routing, which again consists of a mill setup as a starting point, and then lines or arcs or both attached to it. So in further videos we will go over more of the routing commands, and both linear milling and arcs. There's many arc commands, and we'll also go over a lot of the machining commands that make lead in and lead outs very easy, and we can do radiuses and bevels and lots of powerful features to make our routing commands easier to work with and modify as we write our programs.